Hello everyone, welcome to GAE channel. This is Amy. I'm an engineering manager and have been in this field for over 15 years. Our videos cover all essential aspects of electrical design. Most of the content are referring to a recent published book, Practical Power Plant Engineering. This book is a result of 50 years of practical experience from working in different industries and by associating with many experienced engineers. The author of the book, Zach Batlev, is a very intelligent, knowledgeable, and experienced electrical engineer. Without further ado, let's have a look at the different types of power plants. The types of power plants are classified depending on the type of fuel used. For the purpose of bulk power generation, thermal, nuclear, and hydropower are the most efficient. In most cases, the renewable resources are located away from the load, and the power produced transported to load centers by long transmission lines. On the other hand, the generating plants using fuel and built closer to the load centers, and the fuel resources are transported to the plants. Let's find out in detail how these power stations work. First, let's have a look at hydroelectric power plants. Hydroelectric power plants are one of the most effective and eco-friendly of all power plants. In a hydroelectric power plant, electricity is generated from water. In detail, the potential energy of water is converted to electrical energy. When water is made to fall from a height on the turbine, it spins the armature, which is connected to a generator. When the turbine spins, the generator starts to produce electricity. The electricity is then routed to all the different substations to distribute the power. The hydropower is dependent on the product of water head and water flow. This is a formula to calculate the power, where P is a power measured in kilowatts, W is a specific weight of power, 9.81 is a gravitational constant, H is a height of fall in meters, eta is the overall efficiency of operation. It is a product of all of the component efficiencies, which are normally the turbine, drive system, and generator. The advantages of hydropower plants are, it is clean energy with low production cost. The resource is adaptable to changing demand. It can be used as a base or peaking power, and a quick start within 1 minute. Also, it can be designed as a synchronized condenser to provide MVRs, relatively simple operation and maintenance, and a high efficiency, usually at 80 to 85%. The disadvantages of hydropower plants are, it needs large capital cost for civil works. It has relatively low capacity factor, ranging from 15 to 50%, and the water inflow are not predictable. Now let's talk about thermal power plants. A thermal power station converts heat energy into electricity. Typically, water is heated into steam, which is used to drive an electrical generator. After it passes through the turbine, the steam is condensed into a steam condenser and recycled to where it was heated. The greatest variation in the design of thermal power stations is because of the different heat sources, including coal, natural gas, waste, or petroleum. Thermal power plants are designed on a large scale for continuous operations and base loading. The majority of plants use 1 or 2 400 to 600 volt megawatts units. The advantages of thermal power plants include base load operation, low capital cost per kilowatt hour, high capacity factor ranging from 60% to 70%. The disadvantages include pollution, slow startup time, and high standby operational losses from year to year. Now let's talk about gas turbine plant. Gas turbine plant uses a combustion engine that converts gaseous or liquid fuels to mechanical energy. The gas turbine engine compresses air and mixes it with fuel that is then burned at high temperatures, creating a hot gas to make the turbine blade spin and turn a generator as it exhausts gas into atmosphere. The burning energy is converted into electricity. The efficiency is usually less than 30%. The gas turbine plants are built with multiple units of 10 to 250 megawatts each, with a possibility of adding combined cycle thermal generation on every pair of turbine units by using the exhaust gas temperature reaching 540 Celsius degrees C. The advantages of gas turbine plants include low capital cost, quick plant construction, waste heat recovery possibility, quick engine start of peaking duty, and suitable for small remote communities. The disadvantages include high fuel cost and environmental emissions issues.